Let's discuss and understand what is the meaning of adjoint of a matrix. Okay, now here we are going to we are going discussing a very important topic, adjoint. Okay, see, when we say adjoint of a matrix, the first thing is we have to have a square matrix. Okay, now the definition of adjoint is very easy. Now remember, all of you, the cofactor. In the last couple of videos we have discussed and we have done problems on cofactor. So first thing is we calculate the cofactor matrix and then we transpose the cofactor matrix. That becomes the adjoint of a matrix. Okay, now I'll just show one simple example for a 2 cross 2 matrix, because 3 cross 3 is quite hard to do it and it's quite lengthy also. Let's take an example of A, 5, 1, say 2 and 3. This is the matrix. Now we have to calculate the cofactor matrix of A. Okay, and then we transpose it. So first, for the cofactor, we are going to do, so A11 is equal to 3. Next, A12 is equal to -2. A21 is -1. And A22 is equal to 5. Correct. So the cofactor matrix, so here I'll write the cofactor matrix. So this is going to be 3 -2 -1 5. This is the cofactor matrix of A. Correct. Now transpose this one. That becomes the adjoint of A. Okay, again I'll repeat. Take the cofactor matrix, then do transpose of it. That is going to give you the adjoint of matrix A. So in this case, when you take the adjoint, basically when you take the transpose of the cofactor, then we'll get adjoint of A. Adjoint of A becomes 3 -1 -2 5. This is basically what we call as adjoint of matrix A. Okay, so clear? Understand how to calculate the adjoint of matrix. Cofactor, transpose. Fair enough? Okay, now since we have understood what is an adjoint, there are certain properties of adjoint of matrix. Around 3-4 properties are there. 3 properties are there. Very easily we can finish it. Okay, let's start with property 1. The first property is basically what you have as adjoint of A into A. Matrix A is equal to A into adjoint of A. Both of them are equal to determinant of A into I. I being the identity matrix. Suppose if you take a 3 cross 3 matrix, you'll calculate A into adjoint of A. So both of them are 3 cross 3 anyway. So the multiplication has no issues. Then we calculate the determinant into I. I3, I2 depends. Now here a very important point comes. What if the determinant is 0? Then we call such a matrix as singular matrices. In the sense, for singular matrix, the determinant value is 0. Fair enough? This is the first property of adjoint of a matrix. Alright? The second property related to adjoint of matrix is, see, suppose say, second property is, we have adjoint of A. You take the determinant of adjoint of A. Okay, and then we raise it to the power of n. The second property, see, in the second property, we have adjoint of A. We take determinant of adjoint of A. Then this becomes determinant of A power n minus 1. Okay, power n minus 1. Now here n is the order of the matrix. Suppose if you take 3 cross 3, then n becomes 3. If you take 2 cross 2, n becomes 2. Like this one. Okay. So these are 2 important properties or major properties of adjoint of a matrix. Okay. Now in the next video, we'll discuss more about inverse. Then we'll do problems on both inverse as well as adjoint in the upcoming videos. Okay.